Hello guys, and welcome to this full course about Matplotlib. In this video, we are going to talk about the most used graphs in data science, and we are going to plot that using Matplotlib. So, we start by a small definition. Matplotlib is a Python library used for data visualization, with NumPy, which provides arrays, and pandas, where we define data frames. These three libraries can be used together and form an environment in which data visualization becomes easy. Matplotlib is composed of three layers. We have the scripting layer with the Pyplot. We have the artist layer, where we are going to talk later on about the object-oriented programming using Matplotlib, and we have the backend layer. In our case, we are only interested in the scripting layer and the artist layer. For the backend layer, it is mainly used from developers of Matplotlib. Data visualization with Matplotlib is defined inside a figure, which is the top-level container of all plots elements. It includes everything visualized in a plot, including one or more axes. Axis, as I highlighted here in red, it is not a plural word of more than one axis, defined inside the figure as the area where we define the plot and where we find the text, the coordinates axis, x-axis, y-axis, and for the 3D visualization we have the z-axis, the title, labels, legend, text, markers, grid. As you can see here, we have the top level, which is the figure. Inside the figure, we have the axis. And inside each axis, we find the plot elements. As I mentioned earlier, we are going to talk about these two main interfaces of Matplotlib. We have Pyplot, which is first developed to be like MATLAB, and we have the object-oriented programming, where we are going to use objects to plot our graphs. All Pyplot commands make changes and modify the same figure, which means that it works like MATLAB. It is the simplest method for creating plots, whereas for the object-oriented programming with Matplotlib, it is used with advanced plots. When handling multiple figures axes, plots are represented by axes and each subplot is assigned to an axe, which makes modifications on the plots much easier and not confusing. I have put axe, not axis, because usually we use axe and fig to represent our axes and figures in object-oriented programming with Matplotlib. First, we start by line chart. A line chart is a graphical representation that connects a series of data points with a continuous line. Line charts are the most used graphs in data science, and they are mainly used for time series. To demonstrate that, we are going to use the Jupyter Notebook and we are going to use the Matplotlib library. First, we have to import our packages. We have NumPy, we have pandas, and we have Matplotlib. In our case, we are going to import Matplotlib and the Pyplot library. So, import matplotlib.pyplot, and we are going to import that as plt. Okay. Now, if you don't have these packages installed, you can use pip install and you write your package. For example, matplotlib. Okay. In our case, we have matplotlib installed, so we are not going to execute this instruction. To check, for example, version of matplotlib, use matplotlib.version. Okay. So we have 3.3.4 is our version for Matplotlib. So to create a chart in Matplotlib, we have first to create our figure. Since here we have started with Pyplot, which is the simplest one to create visualizations, so we have to create our figure. We use plt.figure, right? So this is used at the beginning of all your codes where you want to create a data visualization. Now we can create our x-axis. So we create, for example, a list of, let's say, 10 values, right? And for example, we create y, which is equals to the square of our variable, which is x. So to create a line chart, we can write plt.plot. So we use the plot function, and you write x and y. In order to visualize that, you have to use plt.show. So here we have our line. We have the values from 0 to 10, and we have the square of our values. This is the simplest graph, and we can modify that. For example, we can change the, let's say, the color. We can add a label. We can change the line width or the line style. To do that, for example, we start by the color. By default, it is blue. Okay, to change the color, we can use color equals to, for example, red. and will give us a red color. Or you can just use C and it will give you the same thing. Okay, so you can use color or you can use C. We can change the line style. We can write line style. Okay, for example, we put it line style. Okay, so we can change our line style. Here also you can just write ls. So line style or ls is the same thing. Or you can write the line width. So line width, for example, we can change it to, for example, let's say 2, right? Okay, or we can say here 4. You can also here use, instead of line width, you can use LW. Okay, you can also add an axis, for example, plt.x label. So we write, for example, x axis, and you can write plt dot, for example, y label, and you can write y axis. Okay, so we have x axis and we have y axis. If you want to change the size of your axis, you can write font size. For example, you can change it to 40. So for the x axis, we see that it is larger than the y axis. Okay, so if you want to do the same for y axis, we can only add it in here and we use that. Okay, so we have x axis and we have y axis. We can also add a title, so plt dot title, for example, we write, for example, first line chart. Okay, the same thing, if we want to change the size of the title, you can write, for example, font size, and we can change it for 16, for example. Okay, so we have the title, we have the x-axis, and we have the y-axis. We can also add a grid, so we can write plt dot, for example, grid, and you can choose the color, for example, it was to gray, for example. Okay, or you can just leave it as it is. Okay, so we have our grid, we have our title. We can also add a legend. Okay, so plt dot legend, but before adding a legend you have to give a name, or you have to label your graph or your line chart. In our case, we can write, for example, we write label, and you can, for example, write y equals to, for example, x square. Okay, so we have plt y equals to x square, and you can change, for example, the position of your legend. You can write, for example, log equals to, for example, you can write it here, it is in the upper left. You can, for example, write upper center. Okay, so it will be in here, right? So as we have said earlier, we create our figure and we have our axis, since we have using the Pyplot, so we are modifying the same axis and the same figure. We have the labels, the x-axis, we have the y-axis, we have the title, we have the grid, the legend, and we have our x and y. We can also save this figure by writing plt dot save fig, right? And you write your title. For example, you write line chart dot png, and you will find your figure downloaded in the location that has been set for this notebook. Now, for example, as you can see here in the figure, we have the steps from the beginning to the end is 2. So we have from 0, 2, 4, 6, 8. We can, for example, change that, the text. For example, if we want from 0 to 2, we have 0, 1, 2, 3, 4, 5, 6. To do that, we use the text. For example, for the x-axis we can use plt.x text, okay, and you write here, for example, np.range. So if we have from 0 to 10, okay, and we have the step is equal to 1, okay. So if we do that, we will have our grid as the following. So we have 0, 1, 2, 3 until 9, okay. Now if we want, for example, here to have the steps of 5, okay, so we write, for example, plt dot y text, for example, okay. So we have np dot range, same thing, we have from 0 to 10, and we have step which is equals to 5. But if we do that, we will get something from 0 to 10, okay, because here we have from 0 to 9, and we got our steps as 1. But here if we do this, we'll get the following, okay. So we have 0 and 5. The value in here will depend on your axis. Here our y-axis is going to 81, so we write 100, okay, and we will get this. So we have 0, 5, 10, 15, 20 until 95, okay, but our value stops in here. So we have 9, square of 9 is 81, okay. So the text is used if you want to arrange, for example, here in our case it is the grid. We can also create another chart in the same figure, okay. For example, if we want to create y2 equals to np dot, for example, power 3 of x, okay, we can do that, and we can plot that by writing the following: plt dot plot, we have x and we have y2, okay. So we will have here our two graphs in the same figure, but we have to change, we don't do this anymore, so I just showed you how to change the text in your figure, okay. So now we have two graphs in the same figure, okay. We can do and apply the same modifications for this plot, okay. For example, we can change the color, we can change the line style, the line width, the label, okay, and it will be directly plotted. For example, if you put label equals to, so we have y which is equals to x cube, right? So it will give us y equals to x cube in blue and y equals to x square in red, okay. Now, for example, if we want to create these two graphs in two separated subplots, and if we want, for example, we have an x-axis as a shared axis between these two, or the y-axis as the shared axis, we can use subplot to do that. So we create a new figure. And by the way, if we want to change the size of our figure, we can use the fig size equals to, and you can write, for example, here 7, 6, okay. For example, we have our x and our y, we just copy that, okay, and we said that we want to create these two graphs in two separated subplots. So to do that, we copy this, so we have the first graph and we do have the second graph. To create the first subplot, we write plt dot subplot, and the first parameter is the number of rows. So here, for example, we want to have the x-axis as the shared axis, so we create 2 rows, 1 column, and it will be in position number 1, okay. The second graph or the second plot, we write plt dot subplot, okay. So we said that we have 2 rows, we have 1 column, and it will be in position number 2, okay. We write plt dot show. So we get our graphs. We have the x-axis as the shared axis, okay, and we have 2 rows, 1 column. If we want to add all this, for example, the legend, the grid, the title, we can just copy that because it will be the same thing. Okay, we can do that for the first graph, and we can do that for the second graph. Okay, so it will not be showed exactly as we want to. For example, we can remove the title from the second plot. Okay, and for example, if we do that, we don't have the title, we can remove the axis since we have the shared x-axis. Okay, so we can just we will remove the x label. Okay, and we can change, for example, the title as this second, or we can write, for example, second line chart. Okay, so you get the idea. Okay, we can create these graphs using plt.subplot into separated plots. Okay, just be careful, it is subplot, not subplots, because when we are going to use the object-oriented programming with Matplotlib, we are going to create the figures and the axis using subplots with an s at the end. As I said, we only create 2 subplots in the same figure, and we can change the size, for example, to 10. Okay, so we can change the size of our figure, and this is useful if we want to create 2 plots in 2 separated subplots, and for example you want to have the x-axis as shared, or if you want to choose the y-axis as the shared axis, so you create here 1 row and 2 columns. Now we'll talk about the object-oriented programming with Matplotlib, and it is used as the following. So we write fig x equals to plt dot subplots with an s at the end, and you write the number of your rows. For example, we want to create the representation with 2 rows and 2 columns, so you write n equals to 2, and you add your fig size. Okay, so in our case, for example, fig size, we want to put it, for example, to 20 to 15. Okay, we are going to use these 2 first plots that we have created at the beginning. So we have x and y, right? We call this y1. Okay, and we want to add 2 more graphs. For example, we can add trigonometric functions like cosine and sine. To do that, so we call this x1, and we call x2 equals to, for example, np dot arrange. Okay, and it will be from 0 to 50, for example. So we call y3 equals to np dot sine x2, and y4 equals to np dot sine of x2, or cosine of x2. Okay, so for the object-oriented programming, it is used by calling objects. In our case, our objects are the axis and the figs. So to create the plots, we are going to work as follows. So write x 0 0, okay, dot plot. So we have, for example, x1 and y1. So we have label, we call it, for example, we have y, it is equal to x squared. Okay, and for the color we can put it, for example, as red. Then we have to add, for example, our labels. Okay, so we have x 0 0. So dot, we don't write x label, but we write set x label. Okay, and we'll call it, for example, x axis. Okay, and it will be font size. Okay, font size equals to 14, for example. We do the same thing for the y axis, so we write set y label. Okay, and we write the y axis. We can also add a title, so x 0 0 dot, so we have set title. Okay, we put it, for example, first plot. Okay, we can add the text. Okay, so we have x 0 0 dot, we also write set x text. Okay, and as before we can write np dot range, and for example we start from 0 up to 10 with a step of 1. Okay, so we have the x label, we have the title, we have the x text. We can add also the legend. For example, for the legend it will be only with legend without the set, so we write legend, and it is the same thing for the grid. Okay, so 0 0 dot, for example, grid. Okay, so we have created among our 4 graphs, so we have 2 rows and 2 columns. We are going to need 4 graphs, or are going to plot 4 graphs. What we can do here is that we can copy all this, since we have 4 and we passed it 3 times. Okay, so 1 2 and 3, and we have at the end plt.show, but we have some changes that we have to do. For example, if we want to change it to the first row and we stay in the same column, okay, so here we only change this to 1. Okay, we are going to plot the legend and the grid as we had in the first subplot. So we have here the second one is x cube. Okay, so we are going to plot that, which means that we can write y2. We have here to change it, for example, to second plot. Okay, and we have done with the second graph. Okay, so for the x text it will be the same. For the title we have changed it, x-axis, y-axis. The color, for example, we can put it to green. And we have done with the second plot. Okay, because we are going to plot it with x1, and here it is the same thing with x1. So we have the first part is done. Now, since we have 2 columns and 2 rows, so we have used the first 2 rows with the first column. Now we have to change that to the first row and the second column. Okay, so we have to change it to 0 1, and you keep in your mind that it is like a matrix. Okay, so it is a 2 by 2 matrix, and you are going to work with that using the axis. Okay, so here we have the x2 and we have the y3. For example, if we want to print the sign, okay, and for the color, for example, we can put it to yellow. For the x it will be the same. For the text we don't need that. For the legend and for the grid, for example, we also don't need a grid. Okay, so here we do have the third plot. Okay, and we have done with this. So we have to change it with x2 because we have another x. Okay, and we want to print the sign of x2 for this one. So we have the second row and the second column, so we change everything to 1. Okay, so for the rows we have done with 1, and we do the same thing for the columns, so it will be x1 1. For the x it will be x2. For the y it will be y4. For the label here we didn't change the label, so it will be y equals to sign of x. Okay, and here for example the color we are going to put it as default in blue, and y equals to cosine of x. So we have the fourth plot, and we don't need text, we don't need the grid. Okay, so if we're going to plan that, we are going to get the following. Okay, so we have sine of x, we have x squared, we have x to the power of 3, and for example here for the legend we can change it, for example, to the upper right. Okay, for example the legend we put lock equals to upper right. Okay, to be more clear, you see, so it is upper right, and here it is upper right, so it is upper left, and here it is upper left. So the idea is we are going to work with axes. You have to keep in your mind that the axes are going to be like matrix. So in our case we have 2 rows by 2 columns. We call the axis by the number of the row and the number of columns. So we have here a 2 by 2 matrix. So here 0 0, we have 0 or 1 0, so we have 0 1, and we have 1 1. Okay, and for example when we want, for example, to name the labels, the x label, the y label, and the title, we use the set. Okay, and the same thing for the text, the x text or the y text, have to use the set. So the object-oriented programming is used for more complicated graphs, and when we are dealing with a lot of figures and axes in our data analysis and data visualization. Now we are going to talk about the area chart. The area chart displays graphically quantitative data. It represents the change in one or more quantities, generally over time. To create an area chart, we first create a line plot. So we are going to copy the first graph that we have plotted. We passed it in here, so we only need y1, for example, and we don't need the second. Okay, we don't need the line style or the line width. Okay, so we don't need that. Okay, so we are going to plot that. Okay, so we don't need the legend, right? So we have here our line chart. So the steps to create the area chart is, as I said, we create the line chart as we have here in our example. Then we add the following. So we write plt dot fill between. We have x and y. Okay, so we do have our line chart filled between x and y, which will be called the area chart. Okay, for example, if we are going to use the sign of x, for example, okay, for example, we are going to put that, and we plot x2 and y2. do a fill between x2 and y2. What is the error? I must have the same dimension but have seems. No, I said x2 and y2 and y3. Yes. What is the x and y? x2 and y2. Right. Yes. So we delete this and we have our chart. Okay, so for example, if we fix size, put it for example to 13 by 10, so we get this following sign function which is filled between the x and y. Okay, so remember the steps to create the area chart is first to create your line chart and use this function, which is plt.fill between your x and your y. A histogram is also a very used graph in data science and in data analysis in general. It is a graph that represents a distribution of a continuous quantitative variable. So here we are going to use data frames. To do so, we are going to import a CSV file and work with that in order to plot our histogram. And I will put this file in the description, so you are going to find directly the CSV file on Kaggle. So I will put the link to the dataset in the description. Okay, so we have here our data frame. Okay, now by definition, a histogram is used to represent a quantitative variable by a distribution. To create our visualization, we first create a figure. So we write figure, okay, and we write plt.hist. For example, we want to have on the x-axis the age. Okay, so we have here different classes, as you can see, 60, 65, 75, 65, and we want to count the total for each category. Okay, so we are going to write df, and we have age, so it will give us this following histogram. For example, we can change that, so we have 2, 4, 6, 8, 9, 11, 10, 11. So we can change the number of beans. Okay, so the beans, we put that to 11. Okay, so from 40 to 95 we have 11 categories, so 40, 45, 50, 55, and we call this the beans, so we have 11 beans. Okay, and for example, if we want to define the edges, so we write edge, for example, color equals to, we can put it to black, for example. Okay, so we do have that, and if we write plt.show, we are not going to get the following arrays. Okay, for example, we can change the color to yellow, and we can add a title. For example, we write plt dot title, for example, and we can write for example, histogram example. Okay, histogram example. We can also add the x label, for example, plt dot x label, and you can write the age, plt dot y label, which is going to be, for example, the count or the total. Okay, so this is how we create histograms using Matplotlib. So we use plt.hist, we put here our variable, we can write the beans, the edge color, for example, you change the color, you can add the title, x label and y label. And here in this case, we have used a data frame. As we have mentioned at the beginning of this video, we have said that NumPy, Matplotlib, and Pandas can work together in order to provide us with an environment in which data visualization is easy. The fourth graph is a bar plot. A bar plot is a chart that shows the relationship between a numerical variable and a categorical variable with rectangular bars. The height of the bars is proportional to the value they represent. So we'll have the first variable, for example, a list of 10 variables, and we are going to have a variable called bar, and it will be the square of x. Now we'll create another figure, and if we want to print that, we write plt dot bar x and bar. So we have plt dot show. Okay, as you can see in here, so we have the height of the bar is proportional of the value of the bar. So we have from 0, 0, 1, 4, 9, 16, etc. So we can increase the size of our figure. For example, we put 12 by 6. Okay, as you can see in here, and we can change the color, for example, into red. We can adjust the width, for example, if we want to make it. We can also add legend. For example, you can write whatever we want in here. For example, we write red bars. Okay, and we add our legend in here, plt dot legend. Okay, so we have our legend in here. We can also add a title, so plt dot title. So we write bar chart. Okay, so for example, we can add an x-axis. Okay, so plt dot x label equals to x-axis. So we can add the y label, y-axis. Okay, so for example, x-axis and y-axis. We can also add the values or the height of the bars on the top of each bar. For example, we can use this for loop. So we have for x coordinates, y coordinate in. So we create zip x and bar. We write plt dot text, and we have x coordinate, and we put the values plus, for example, our dot 5, and we write our value. So we write our coordinate, and it will be in the center. Okay, so we have added the values of each bar on the top of the bar using the for loop. We can also create the same, for example, plt dot figure. So we have the fig size, which is equals to, for example, 10 by 10, and in here we can add a horizontal bar chart by writing the following. So plt dot show. So we can create the horizontal bar chart by using bar h, or we can create bar chart, vertical bar chart using plt dot bar. A scatter plot is a graph that uses dots to represent values for two different numeric variables. As you can see here from this image, for example, we have the age and we have the platelets, and we have represented our data using dots depending on a certain category. So to create a scatter plot using Matplotlib, we first create our figure, then we use plt.scatter. For example, if we use the time in our data frame, and for example, we have the platelets, and we are going to show that, so plt.show. Okay, so here we have our scatter plot. So we can add, for example, the size. So if you put, for example, s equals to 200, so we will get a bigger dots. We can change the size of the figure. So if you put fig size equals to, for example, 12 by 6, So we'll get our graph. We can make our color depend on, for example, the death event, since our data set says that whether the death of the person is caused by some of these variables or not. Okay, for example, if we do df head, so we will have here the death event equals to 1 or equals to 0. For example, if we want to know how many people have a death event equals to 1, we can just use death event, okay, and we count the values, okay. So we have value counts, okay. So we have 203 with 0 and 96 with 1. As you can see here in the image, we have a lot of dots in purple, which means that they do have a death event equals to 0, and the death event which is equals to 1 is represented in yellow. Okay, so we can say that if value of time is less than 70, we'll have a death event equals to 1. Okay, for example, we can add in here, for example, the title. Okay, so we have scatter plot example, for example. Okay, we can add x label, for example. We can put x label equals to time, and the y label equals to platelets. Okay, so we do have our scatter plot, and there is another parameter that is very important in scatter plots. It is called alpha. This alpha will define for us the density of the colors. The higher is alpha, the darker is the color. So we are going to take our code and use it inside a for loop. So we define a for loop for I in range 1 to 7. We pass that, and we define that each figure will define for us one plot. Okay, so we put plt.figure I, and we add here an alpha. So we have alpha, for example, we put it 0.2 times I. Okay, as you can see in here, so we have the density of the color is less in here, and it increases each time we multiply by alpha. Okay, so for example here alpha is equals to 0.2 times 7, which is equals to, or times 6, which is equals to 1.2. okay, so alpha, as I said, will tell us or will give us the density of the color. If we increase the value of alpha, we will get a darker color of our dots. Pie chart and donut chart are circular charts divided up into segments to illustrate numerical proportion. To create a pie chart in Matplotlib, we mainly need segments and labels. So we are going to create a new figure, and we have, for example, segments. Since we have said that it will represent numerical proportion, so we'll have values that we are going to sum up to get 100%. Okay, so we have our segments. For example, we'll take 15, 25, 10, 45, and 5. Okay, and we are going to give labels. So we will have, for example, segment, we call that segment 1, and we copy that. So we have 5, 2, 3, 4, and 5. So this is number 5, 4, 3, 2, and 1. Okay, now we write plt.py. We have the segments, and we put labels equals to our labels. Okay, we are going to show that. Okay, so we'll have here our pie chart. Then we can change our fixed size. For example, we put it 8 by 8. Okay, now if we want to start, for example, by definition or by default, it starts from 0. So we have 0, we have 15, 25, 10, 45, and 5. So we can change the start angle, for example, to 90. So write start, okay, angle will be, for example, 90. Okay, so we start from 90. Okay, we can also display our percentages. For example, if we want to display 15%, 25%, etc., we use the auto percent. Okay, we'll put it equal to, for example, we'll have 1, for example, and we only print 15% without printing, for example, 15.1 or 15.2, since we have integers, and we'll add the percentage. Okay, so we add our percentage, as you can see in here. So for example, if we change this to 45, we will get our data. Okay, 15, 25, 10, 45, and 5. Okay, so this is for the pie chart. To create a donut chart, we have first to create our pie chart. So here we have our pie chart. We copy this code. Okay, we'll have another pie chart. Okay, and if we want to create a donut chart, so we have to add a circle, a white circle in the middle. Okay, so to do that, we have first to create a circle. Okay, so we write circle equals to, for example, plt dot circle will be centered at 0, 0, and it will have a radius of 0.7 with a color white. Okay, we have said that we have to add a white circle in the middle. Okay, so we get the current figure by putting plt dot get current figure. Okay, use this function, and we get our axis to add the circle. So we have our figure, we get the current axis. Okay, and we use add artist. Okay, to add our circle. Okay, we are going to show that. So here we have our donut chart. Okay, so to create a donut chart, we create first our pie chart, and we add a white circle in the middle. Okay, so you can change this, for example, to 0.5, you see, or 0.9. So it's up to you to create your donut chart, but generally we use 0.7. Okay, as you can see in here, we have our donut chart and we have our pie chart. So this is all for Matplotlib. I hope that you have learned new things. Thanks for watching, and see you in the next tutorial.